Once again, I'm going to give you the answers to these three first, but then you should stay tuned for any or all of the video explaining the problem or problems that you missed. Number 4 is 56. And that one is often missed, so I hope you'll stay tuned for the video part of that one if you got the wrong answer on that one. Number 5 is 10, and number 6 is 15. The reason number 4 is often missed is because number 4 says, how many ways can 3 people be chosen from 4 couples if all are equally eligible? And so sometimes students will incorrectly think that this is a combination of 4 people taken 3 at a time. But of course, 4 couples is not 4 people, it's 8 people. So this should be 8C3. And so this is 8 factorial over 8 minus 3 factorial, 3 factorial, or 8 times 7 times 6 times 5 factorial, glancing ahead at this and realizing that I'm going to have 5 factorial in my denominator, times 3 times 2 times 1. If you're starting to memorize some of those factorials, that's always helpful because 6 will cancel out this 6, 5 factorial cancels out 5 factorial, and this is why the answer to this one was 56. 8 times 7 is 56. How many ways can a reader select 3 books from 5 different books? So the order of the 3 books will not matter. Books A, B, C is the same selection as books B, A, C. I've got 5 things to choose from, and I'm selecting 3 of them. It's 5 factorial over 5 minus 3 factorial, 3 factorial. These 2 factors in the denominator, sometimes, I think, well, I shouldn't actually qualify that. Let me just say that sometimes the first factor is a larger number, sometimes the second factor. It just depends on how many you're selecting. In this case, the first factor is the smaller factorial, 2 factorial. So I will expand my 5 factorial all the way up to 3 factorial to cancel out the larger factor in the denominator, and I will expand the smaller factor 2 times 1. Cancel out that 3 factorial, 2 times 1 is 2, and when I factor 2 out of the 4, I get 2, and 5 times 2 gives you the answer 10. How many pairs of friends may be chosen from among 6 friends? You've got 6 friends, and you're choosing a pair from that 6. The order wouldn't matter, so 6 factorial over 6 minus 2 factorial, 2 factorial. 6 times 5 times 4 factorial over 4 factorial times 2 times 1. 4 factorials cancel, and 30 divided by 2 is 15.